Alrighty, Patriots. So in this video, what we're going to look at is we're going to look at something called standard deviation. I'm going to give you a definition, what it means, and how we use it. So standard deviation is a measure of how dispersed my data is in relationship to my mean. So basically, if we have a small standard deviation, if our standard deviation is a small number, all of my data is really close around my mean. If I have a large standard deviation, my data is going to be spread out. Oh, that looks weird. There we go. My data is going to be spread out further from the mean. Okay, so standard deviation measures how spread out my data is from the mean or the average of my data. This symbol, again, it's a Greek letter. This means standard deviation. It's the little letter sigma. It means standard deviation. So what does this look like? Let's say I gave you a data set. It has a mean of 100, and I tell you the standard deviation is 15. So if we take a number line, we're going to put our mean right in the middle. So we have a mean of 100. Now what we're going to do is we're going to count up standard deviations. Let's count our standard deviations to the right. So we're going to have 1 standard deviation, little sigma, 2 standard deviations, 3 standard deviations, 4 standard deviations. Well, not only can I get bigger, I can also get smaller. I can have a standard deviation to the left, 2 to the left, 3 to the left, 4 to the left. So what this means for my data, every change in a standard deviation is a change in 15 of my for my actual data. 1 standard deviation is 15 away from the mean. So I'm going to go from 100 to 115. Another standard deviation away is going to be 15 more. So that's going to be 130, 145, 160. We can also count down. 100 minus 15 is 85, 70, 55, 40. Every change in a standard deviation is a change of 15 in my data points. It won't always be 15. Our standard deviation consistently changes values. So let's take a look at a problem. Let's actually do one. So I am going to give you the scores from the first 6 basketball games of this season. There's 75, 83, 96, 100, 121, and 125. We are told the standard deviation is 18. There's a formula to figure it out, but you don't need to worry about that formula in this class. So I'm just going to tell you the standard deviation of these points is 18. Which of these scores are within 1 standard deviation of the mean? So the first thing I'm going to do is I'm going to figure out what the mean is. Remember, this is my mu. Mu means mean. Add up all of my scores, 1, 2, 3, 4, 5, 6, divide by the number of games, and we get a mean score of about 100. So on average, we scored 100 points over these 6 games. Some games were more, some games were less. So we know every standard deviation away from the mean is actually 18 points. So 1 standard deviation up from the mean would be a game that is 118 points. Well, not only could we go bigger, we could also go smaller. So if we go, here's my mean, let's go 1 standard deviation down. 1 standard deviation down is going to be 100 minus 18 because we're getting smaller, and that's going to be an 82. So any point value between 82 and 118 is 1 standard deviation away from the mean. So which games did I score within a standard deviation of the mean? From 83 to 96 to 100. Oh, excuse me. 121 is more than 1 standard deviation away, so is 125. So this is a nice visual representation of a standard deviation. So Robert and Andrea both hit 10 golf balls with a mean distance of 300 yards per ball. What that means, Robert went and he hit 10 golf balls. They measured the distance of every golf shot and they added it up, divided by 10, and they found out that it was 300 yards. So on average, Robert hit 300 yards on every shot, on average. Andrea also hit 300 yards. However, Robert's standard deviation is only 5 yards away from the 300. What this means is his balls are all closer to the 300. Andrea has a standard deviation of 15 yards. That means she hit further away from the 300 than Robert did. Notice Robert's is nice and clustered around the mean. Andrea's is more spread out. Smaller standard deviation for Robert, larger standard deviation for Andrea. It measures the spread of my data. So who's more likely to hit closer to the 300 yards? So if I look, who had the smaller standard deviation? Robert did. Robert is more likely to hit closer to the 300 yards. He has a smaller standard deviation. What that means is Robert is more consistent with his golf shots. He hits, if I need 300, Robert's going to hit 300. If I need somebody to hit longer, what I'm going to do, so who's likely to hit the ball further? Well, who's less consistent? Who has a bigger standard deviation? That's Andrea. Andrea is more likely to hit our balls further because she has a larger standard deviation. Her shots are more spread out than Robert's, so she is less consistent. She hit, not only does she hit further, why it's the same mean is she doesn't only hit further, she hits shorter. So Andrea is not as a reliable golfer as Robert is. Andrea is more likely to hit her balls further, and she's more likely to hit her balls shorter. A larger standard deviation means the spread is more from what I'm looking for. She is a less consistent golfer. If I need somebody to hit 300 yards exactly, go with the lower standard deviation. If I'm looking for somebody to hit it further, I might give Andrea a shot because she's capable of hitting it further. Alrighty, so if you have any, what does standard deviation measure? In one word, standard deviation measures consistency. The lower my standard deviation, the more consistent my data is, the closer it is to the mean. So if I take a bunch of tests and I average up those test scores and I look at the standard deviation and it's a small standard deviation, what that means is I always get that around that same letter grade. If my mean is an 87 and my standard deviation is 2, I pretty much get 87 every time. But if my mean is 87 and my standard deviation is 15, well, I'm going to score. I have some tests that are really large and I have some tests that are really low, but on average it's an 87. So standard deviation measures consistency. Lower standard deviations, again, are always more consistent. Larger standard deviations are less consistent. All right. So I know that last part was a mouthful. So if you have any questions that you still might have, ask your teacher, Patriots, and we can answer those in class. And Patriots, we're going to see you when we see you.